The math skill for the GED on the science test that we're going to look at in this video is using formulas. And it involves a little bit of algebra, and that's why some students have a hard time with it. The good news is most of the time on the GED, when you have to use a formula, they will give you the formula within the question. They don't expect you to have any of these formulas memorized, but they expect you to know how to use these formulas to get the answer. So we're going to look at several different formulas. It may not be all of them. There could be other formulas that are used on the GED other than the ones I'm going to show you today. But if you understand how to put numbers into formulas, it won't matter what the formula is, you'll be able to do this. So the first one we're going to look at is changing temperatures, changing Celsius to Fahrenheit, or actually changing Fahrenheit to Celsius first. So this is the formula. And as I said, you don't have to have that formula memorized. They would give you that formula as part of the question. And the question would probably be a little more involved than mine, but just for examples, the temperature outside is 77 degrees Fahrenheit. What is that temperature in Celsius? So we have this formula, and it tells me Fahrenheit minus 32 times 5 divided by 9 would give me what the Celsius is. So all we have to do is take that temperature of 77 and put it in the formula. 77 minus 32 in parentheses times 5 divided by 9. And once you have the numbers in the formula, we can just take our calculator, and this is a fraction. I can type it in two different ways. I can type in the whole thing. I'd need to put parentheses 77 minus 32 times 5, hit enter, and divide that by 9. Gives me 25 degrees Celsius for 77 degrees. You can, because this looks like a fraction, I can hit my fraction button and put 77 minus 32 times 5, and on the bottom 9, and when I hit enter, the calculator does the same math, follows the order of operations, gives me the answer of 25. So let's do another one like this. Now I have a temperature of 95, so we're going to put that in the formula. 95 minus 32 times 5 over 9. Now notice I didn't put the parentheses. If I type this in without parentheses, we're not going to get the right answer, because the calculator is going to do this 32 times 5 first, because it follows the order of operations and will multiply before it subtracts. So those parentheses are really important in this case. We need 95 minus 32 times 5 divided by 9, and the temperature 35 degrees Celsius. So whatever formula they give you, when they give you the numbers, put them in and then put them in your calculator. Let's go the other direction and change Celsius to Fahrenheit. So now we have this formula where we're going to put whatever number Celsius in for that letter, then for that variable, and we'll put it in our calculator, and it will tell us what the Fahrenheit is. So we want to know 25 degrees in Fahrenheit. So we'll put 25 in the formula where the C is. 25 times 9/5 plus 32. So there's where the parentheses go. In this case, if we left them off, it wouldn't matter because the calculator is going to do that first. But since they're in the formula, we're going to get in the habit of putting them in the calculator that way. So 25 times my fraction 9/5, 9 on top, 5 on the bottom, parentheses, plus 32. Gives me 77 degrees Fahrenheit for the equivalent to 25 degrees Celsius. One other one, 180 degrees. The cake recipe says to preheat the oven to 180. We'll take that 180, put it in for the Celsius number. 180 times 9/5 plus 32. And when I take my calculator, 180 times the fraction, 9 on top, 5 on the bottom, close my parentheses, plus 32 gives me 356 degrees Fahrenheit to bake a cake. So those are examples changing Fahrenheit to Celsius and Celsius to Fahrenheit. Once again, you don't have to have those formulas memorized. They would be part of the question if they asked you to do that. Another one I've seen frequently is calculating density. Density is one of the ones that is more common. Mass divided by volume. So however much mass an object has divided by volume. Density, how tightly packed the molecules or the stuff is in the space. So we want our mass divided by volume. So in this case, when I look at this question, a block of wood has a mass of 200 grams and a volume of 50. What is the density of the wood? So if I use this formula, density equals mass divided by volume. Which number is the mass? 200. That's the number that goes on top where the M is. 200 divided by a volume of 50. 200 divided by 50. I can punch that in my calculator if we need to, but it is 4 grams per centimeter cubed. And that means for that volume, each cubic centimeter would have a mass of 4 grams. If I look at this bottom one, a rock has a mass of 2.5 grams, 2.5 kilograms, and I have 1 liter of water. This one is trickier because when I look at my question, they want the density in grams per cubic centimeter. So you have to know a little bit about the metric system. 2.5 kilograms. There are 1,000 grams in a kilogram. Prefix kilo meaning 1,000. So if I have 2.5 kilograms, multiply times 1,000, 2.5 times 1,000 tells me that is 2,500 grams is equal to this 2.5 kilograms. We also have 1 liter of water. The same thing, 1 liter is 1,000 cubic centimeters. It's actually a milliliter as well. But so this is 1,000 cubic centimeters. But they give you this conversion that you might need if you didn't know it. And we want density equals the mass. Now I know the mass of 2,500 grams and the volume of 1,000 centimeters cubed. When we divide 2,500 divided by 1,000, we get 2.5 grams per cubic centimeter. Now, this came out to be the same. It won't always be that way. If it's just because both of these conversion factors were 1,000 that if I had divided 2.5 divided by 1, I would have gotten the same thing. But if the conversion factors are not the same, if you were converting to something else, then you won't always get that same number. But there's our density of this particular rock, 2.5. So my wood was 4, my rock is 2.5. And sometimes they will also ask you to work backwards. They may give you the density and ask you to find the mass or the volume. So once again, we're going to use this same formula, but we might have to use a little more algebra skills in this one. So a liquid has a density of 2 grams per centimeter cubed and occupies 50 centimeters cubed of space as that volume. What is the mass? So using this formula, it tells me the density is 2. That has to equal something, mass, divided by 50 is my volume. Now, to solve this algebraically, we would need to multiply 2 times 50. In this case, it's math most of you can probably do in your head. What number divided by 50 gives me 2? Well, the mass would be 100 grams. But to solve this, you can think of it in terms of a proportion and think 2 times 50. If you do the cross multiply and divide, 2 times 50 is 100. And 100 divided by 1, we'd get 1m equals 2 times 50 when we solve it. But mass equals 100 once again. Okay, let's look at this other one. A metal block has a density of 8. Still going to use that same formula, mass divided by volume. I know the density goes in for that letter. And in this case, we have the mass going in for that letter. And we're looking for the volume. So 8 has to equal 160 divided by our volume. So on this case, if I think about it like a proportion like I did over here, 8 over 1 equals 160 over my volume. Multiply the two across from each other. 8 times my volume equals 160. Divide both sides by 8. 160 divided by 8 gives me a volume of 20 cubic centimeters. So when they give you the density, like they did in this one, and they ask for mass, or this one, and they ask for volume, it requires a little bit more of those working backwards and those algebra skills to try to solve for that missing piece. But knowing the formulas, being able to put the numbers in, will help you get to the right answer with those. Another one with some physics. There's a lot of math involved in some physics. This is the formula for kinetic energy. Kinetic energy is the energy an object has because it's moving. And if the object isn't moving, it has no kinetic energy. I'll show you how that works here in just a minute. But we want to calculate a car's kinetic energy. This number is the mass. This number is the velocity. And so if you can put those numbers in this formula and put it in your calculator, you'll be able to find the kinetic energy. So the kinetic energy equals half of the mass, that is 1,200 kilograms, times the velocity squared. And so once I have it in this formula, we can just take our calculator and put it in. My fraction button, half times 1,200 times 20 squared. And if I use this x squared button, it'll put that exponent of 2 on there. And that gives me a velocity of, or a energy, 240,000 joules of energy. Joule is a unit of energy. If you study the topic of energy in physics a little bit, you'll get more familiar with that term. So we have 240,000 joules of energy for that car. I mentioned a minute ago, if my velocity is 0, that it has no kinetic energy. So let's say this car has kinetic energy equals half times 1,200 times a velocity of 0. It's not moving. What happens anytime you multiply by 0? You get 0. So if I were to punch that in my calculator, my kinetic energy is 0 because my object is not moving at all. So just know that with velocity and momentum, if it's not moving, there is no kinetic energy, no momentum for an object that's not moving. Now I have a baseball. Notice the mass of the baseball much, much smaller than the mass of the car. So when I use this formula, kinetic energy, half times the mass of my baseball, 0.15, times my velocity, 30 meters per, well, I'm just going to put 30, and I have to square the number. Okay, so there's my formula, half times the mass times the velocity squared. Put this in my calculator. Fraction half times 0.15 times 30. My squared button gives me 67.5 joules of kinetic energy. It's got a lot less, and the reason it has a lot less is because the mass is so much less. The car is going to have a whole lot more kinetic energy when it's moving than the baseball because of the amount of mass that the object has. But the amount of kinetic energy depends on two things: the mass of the object and how fast it's moving. But that's using the formula for kinetic energy. Another one that comes up occasionally is with physics. This one, force equals mass times acceleration. This is Newton's second law of motion. Newton's second law kind of gives us the relationship between force, mass, and acceleration. And it was kind of like with kinetic energy. If you have more mass, it will take more force to move the object. If an object moves faster, it will take more force. But it's a relationship when one of them, when you have more mass, you need more force. Or when you want more acceleration, you need more force. But if you decrease the amount of force, then an object's going to go slower. So the two are related, force, mass, and acceleration. So the first one we're going to look at is we're trying to find what force, and we have to multiply the mass times the acceleration. There's my mass, there's my acceleration. Force equals mass of 10 kilograms times the acceleration of 3 meters per second squared. And what we get when we multiply 10 times 3 is a force of 30 newtons. And so once again, the units, if you study physics a little bit, you'll learn that when you multiply the kilograms times the velocity, you're going to get, or the acceleration, you're going to get newtons of force. So there is one example. The second one, now we got a work backwards question. This one, actually, no, it's not. They give me the kilograms and they give me the acceleration. Force equals the mass of 1,000 times the acceleration of 2. So how many newtons of force? 2,000 newtons of force when you multiply 1,000 times 2 would be the amount of force for moving a car at that rate. If I want the car to move faster, you change this number, it's going to take more force. Okay, so it's the relationship between force, mass, and acceleration. Sometimes they'll have you work backwards. They'll give you the force and ask you to find the mass or the acceleration using this formula. If you take the force and divide by whichever one they give you, that will give you the other variable, mass or acceleration. Okay, and one other one that I have to show you has to deal with work. Work and power are some physics terms as well that you might want to get familiar with. Once again, there's so many different physics formulas and math formulas that could be used on the GED, but I'm just showing you a few of them to get you familiar with how using formulas would work. If they give you the formula, just take the numbers and put them in and then put it in your calculator. So if work equals force times distance, however much force it takes times how far I want to move the object would equal the amount of work that's done. So if I have a heavy couch and I want to move it a certain distance, then we can calculate the work by knowing the mass of the couch and how far I want to move it. A person pushes a box with 50 newtons of force for 4 meters. So force, work, equals force times distance. The force is 50. That goes in for that. That one goes in for my distance. 50 times 4 is 200. Once again, here's the unit of joules of work done. So a newton the unit of force times my distance gives me joules of energy. Okay, this next one, here's one where we work backwards. 200 joules of energy, or joules of work. That goes in for my work side. And there's my distance. So 200 joules equals my force times 5 meters. So we're trying to figure out what number would go in here to multiply by 5 and give me 200. To find the answer, I can, if I had 200 equals 5 times my force, solving that algebraically, we divide both sides by 5. So 200 divided by 5, or 40, is going to give me how much force we have to have. So 40 newtons of force is how much force would be required to make that little cart move 5 meters. So, as I said, there's a lot of different equations, different formulas that might be involved in science. These are just a few, but if you can do a little bit of algebra and know how to put the numbers in for whatever letter they stand for, with your calculator, you should be able to answer these questions. I hope this has been helpful, and good luck as you prepare for your science test.